Today we're going to start by looking at the law of sines. The law of sines is something you did in geometry. A lot of geometry references today, which I know makes you very happy as well. And it starts with this big idea. If you want to solve triangles using, say, SOHCAHTOA, that's great. Pythagorean theorem, it's great, so long as you have a right angle. But as you know, there's many triangles that do not have right angles. So what the heck do we do? Give up? No, because we are tigers and we don't give up. So I've got A, B, and C. I've got a triangle, does not have a right angle. I'm going to create a right angle by dropping a height or an altitude. Forms a 90-degree angle. You might say that's cheating. Don't worry, I'll get rid of it. Settle down. My question to you is, what is this side right here? Okay, AC, isn't it also B? It's across from angle B. What side is this? A. Now, what I'm going to do is I'm going to use these letters and these features in order to write a trigonometric expression. Which trigonometric function involves A, H, and B? Why? Very good. A plus for Samantha. She says the sine of angle A is H over B, opposite over hypotenuse. Everybody see that? So we'll write that down. Sine of angle A is equal to H over B. Now I'm going to grab the second grouping. Which trigonometric function has to do with those? Sine again. Sine of angle B is what? H over A. Hey, both of those expressions have what? An H. I'm going to solve for the H. I'm going to multiply both sides by B. B times the sine of angle A is equal to H. I'm going to multiply both sides by A. A times the sine of B is equal to H. Hey, wait a minute. If they're both equal to H, then they're equal to each other. So B times the sine of angle A is equal to A times the sine of angle B. I told you before that we would get rid of the H. We now have an expression that involves angles of a triangle and sides of a triangle. That does not involve SOHCAHTOA. It does not involve the Pythagorean theorem. And although it looks kind of cool right now, I can make it look even better. I'm going to do one last thing. In an equation, you're allowed to divide both sides by the same thing. I'm going to divide both sides by AB. If I divide both sides by AB, what happens? B's cancel, A's cancel. Sine of angle A over side A is equal to the sine of angle B over side B. And it turns out that that's equal to the sine of angle C over side C. What did we just do? We did a very shortened proof of the law of sines. The law of sines is not something that people just make up. It comes from basic operations of trigonometry. You saw how we took all that stuff there. You guys worked it through with me. This is truth. Works out. It's beautiful. But it requires that we know an angle and its opposite side. Notice sine of angle A and then the opposite side, side A. So if you want to solve a triangle, we can use the law of sines. We're going to solve these two triangles for our lesson today. Angle A, angle B, angle C. Side A, side B, side C. How are we doing? Is everybody okay? Is everybody okay with how I drew the triangle? Now, you understand that in our previous work that we would always say that C was what? 90 degrees. That's different now because we don't necessarily have a right triangle. Now, I know you could find angle C because all of the angles add up to 180, but we're going to just leave that aside for just a second. We need to talk about something else. I'm going to teach you something that you maybe did not really understand when you first took geometry, but you're going to understand it now. Okay? I'm going to have this up here. I want you to flip to the very back page. Do you recall these? These are from geometry, and some of them were triangle congruence theorems, which meant if you had two triangles who had these properties, then they were going to be congruent. Angle, angle, angle was not one of the congruence theorems. That only showed that two triangles were similar. So if we are given three angles in a triangle, we can't solve it. Do you remember which ones of these up here worked and which ones did not? Angle, side, angle did work. Angle, angle, side did work. The donkey did not work, right? Side, side, angle spelled backwards is booty. And that's a problem. All right. So, donkey situation is bad. But side, angle, side is fine. And side, side, side is fine. The only ones up here that don't work are angle, angle, angle. And sometimes side, side, angle doesn't work. Sometimes it does. Sometimes it doesn't. We're going to talk about that in a little bit. So you tell me. The triangle that I have right here, which one of these six is it? Which one of the six is it? Okay, it's two angles and it's one side. So that means it either needs to be angle, side, angle, or it needs to be angle, angle, side. How? Okay. You are 100% correct that if you were given two angles, you're going to be able to find the third, right? And so they end up working out the same. But there's going to be times where that's not the case. For example, in our second one, where it really does matter. So let's understand which of these three is it truly? Or which one of these two is it? Why do you say it's angle, angle, side? Okay. So here's how it works. When you try to decipher, if 10 was right here, then it would be angle, side, angle. Because, look, the side sits between the two angles. Do you see that? This is the side between the two angles. But look, is the 10 sitting between the two angles? No, it's sitting apart from the two angles, which is why we say that one. That's so important that you see that. It's going to come into play the rest of the way. And we'll examine it again over here. So what you do is you look at your decision tree, and it says if you have angle, angle, side, one solution, use the law of sines. So I'm going to use the law of sines. And I set it up. Sine of what? 42 over 10 is equal to sine of 80 over b. Excellent. I cross multiply. I get 10 sine of 80 is equal to b sine of 42. Divide both sides by the sine of 42. That's going to give us the result. Yeah, we should make sure that we're in the right mode. So I'm saying degrees. If you're not saying degrees, it's going to be a problem. Press enter. I get 14.72. Samantha was correct. Sam said, well, Mr. Gantz, I'm not sure if it's right. Well, I can't tell you for sure if it's correct, but I can tell you if your answer is reasonable. Angle A is smaller than angle B, so therefore side A should be smaller than side B. Can we find angle C? How? Or we just know that all the angles add up to 180. Subtract the 80 off, I get 100. Subtract 42 off, and I get 58. Can I use the Pythagorean theorem to find C? Why can't I use the Pythagorean theorem? It's not a right triangle. So you have to set up the law of sines. Go ahead, set up the law of sines, and find side C on your own right now. Ready, set, go. All right, what'd you come up with? Somebody show braveness. We got 12.67 coming from Mishika. Could somebody confirm it? I got 12.67. I have multiple people confirming it. We're going to go with it. I'm going to check the reasonableness of my solution. Looks like angle C is between angle A and B, so side C should be between side A and side B for length. We good? Sure. 6, 7, 6, 8. I'll have some wiggle room on the 100th, okay? But try to put it to the nearest 100th if possible. Got it? Okay. One more example, then you can have your worksheet. It's a worksheet. In honor of Riker, I'm going to try to stay away from packets. Getting a little precipitation out there. Nothing enough, I don't think, this week to call school or anything, but please make sure that you are safe on the roads. It can be deceptively slippery with how cold it is and the moisture we're getting. I would say no. I don't believe it's gonna be bad enough. I think you guys need to give yourself time, take time, drive safe. Okay. All right. Now, which of the which of the 6 scenarios do I have here? I'm hearing side, side, angle, angle, side, side. If I start with the 12, it would be side, angle, side, right? So which is it? No. If you write it out, and again, this is what we have to work through. These are my 2 options. We know we have 2 sides. Look, here the angle sits between the 2 sides. Look at angle 12, or look at side 12 and side 10. What's the angle that sits between 12 and 10? C. Are you given angle C? No. So therefore, it's not side, angle, side. You're given an angle that is not between the 2 sides. So it's donkey. Exactly. No. Some cases, it's no solution. But let's check it out. Go to your decision tree. We have to make an important observation. We see we've got donkey, so we follow it down. We either go to the left or we go to the right. And we ask ourselves, is the side opposite the angle shorter than the other given side, or is the side opposite the angle longer than the other given side? It's longer. So I look at this and I say the side opposite the angle is 12. That's longer than the other side. And it says as long as that's the case, there's one solution and you use the law of sines. Tomorrow, instead of going to the right, we're going to go to the left. And tomorrow is the most complicated lesson and the most important lesson for you to figure out to do well on the test. But fortunately, you're going to be here. Okay? So let's write it out. 12 degrees. Side B is 12. Side A is 10. What am I solving for right now? Angle A. Sine of 12 degrees divided by 12 is equal to the sine of A divided by 10. I'm looking for angle A. Now, as you cross multiply, notice I could just multiply by 10 over here. I have 10 sine of 12 degrees divided by 12 is equal to the sine of A. What's different about this situation is I'm looking for an angle. Very good. Ishika is on the ball. She sees it. Let's make sure everybody else does as well. We've got 10 sine of 12 parentheses divided by 12. I get 0.17. Does that mean that the angle is 0.17? No. We inverse sine inverse. Hey, stop that. Sine inverse. And I could just do second ANS to get the answer. Saves me some time and effort. And I press enter. I get 9.98. So that means angle A is 9.98. Now, a lot of people are like, hey, that doesn't sound right. That's a really small angle. Well, should it be bigger than 12 or smaller than 12? Why? Side A is smaller than side B. Exactly. Can you now find angle C? Yeah, you take 180 minus that answer minus 12, and you get 158.02. Great. I've got 158.02 degrees. Can I now find side C? And there comes a time where you maybe don't even feel the need to cross multiply. As I set it up, sine of 12 degrees over 12 is equal to the sine of 158.02 degrees over C. And if you were to cross multiply in this situation, you can see that you would take 12 times the sine of 158, and you would end up having to divide it by a sine of 12, right? So I'm just going to do that all in one operation. 12 sine of 158.02 divided by the sine of 12. And when I do that, I get 21.60. And it should be my longest side, and it is. These are not that bad. I'm going to give you a worksheet today, and it's going to have more problems than you need in order to understand what's happening. But the reason why you have a little bit more problems than what you need is because you need to become quick with this. Because on the test, when you're asked to do the law of sines, it needs to be fast, because we're going to ask you to do more complicated things than just the law of sines. So I want you to become really quick at it and really good with it. We all good? All right. Good job, folks.